Hi everyone, welcome to this topic, the client-server relationship. The first point, client and server interaction. Every day, we use a service available over networks and the internet to communicate with others and to perform routine tasks. We will think of the servers, client, and networking devices that are necessary in order for us to receive an email, update our status on media social, or shop for the best bargains in online store. Most of the commonly used internet applications rely on complicated interaction between various servers and clients. The term "server" refers to a host running a software application that provides information or service to other hosts that are connected to the network. A well-known example of an application is a web server. There are millions of servers connected to the Internet, providing services such as websites, emails, finance transactions, music downloads, so on. A crucial factor to enable the complex interaction to function is that they all use agreed-upon standards and protocols. An example of client software in a web browser like Chrome or Firefox, a single computer can also run multiple tabs of client software. For example, a user can check email and view a web page while instant messaging and listen to an audio stream. The table lists three common types of server software. The first is email. The email server runs email server software. Clients use mail client software such as Microsoft Outlook to access email on the server. The next type is web. The web server runs web server software. Clients use browser software such as Chrome or Firefox to access the web page on the server. And the last type is file. The file server stores corporate and use files on a central location. The client device accesses these files with client software such as Windows File Explorer. Uh, the next topic is URI, URN, and URL. Web resource and web service such as RESTful APIs are identified using a Uniform Resource Identifier (URI). A URI is a string of characters that identify a specific network resource. As shown in the figure, a URI has two specializations. The first is Uniform Resource Name. This identifies only the namespace of the resource, web page, documents, image, so on, with reference to the protocol. The next is Uniform Resource Location (URL). This defines the network location of a specific resource on the network. HTTP or HTTPS are typically used with web browsers. Other protocols such as FTP, SFTP, SSH, Security Shell, and others can be used as a URL. A URL using SFTP might look like this address. These are the parts of the URI and shown in the figure. Protocol Scan, HTTP, or other protocols such as FTP, SFTP. The next is host name, how this, and the next is path and file name, and the fragment parts of the URI. This is the URN, URL, fragment, and URI. And packet tracer, the client interaction. Okay. In this activity, you will observe the client interaction between the server and PC. Go ahead. Objectives: observe the client interaction between the server and PC. Background: clients such as desktop PC require service from server. The lab environment, using physical PCs and servers, supports a full range of servers in a simulated environment. The number of servers the number of service is limited. Packet Tracer allows the addition of simulated network servers that support DHCP, DNS, HTTP, and TFTP. Packet Tracer also supports the addition of simulated PCs that can request these services. This activity uses a simple network consisting of a PC connected directly to a server configured to supply DNS service as well as host a web page through an HTTP server. This activity will track the flow of traffic that happens when a web page is requested, how the IP address of the web page is resolved, and the web page is delivered. Instruction Part 1: Enter simulation mode. When Packet Tracer starts, it presents a logical view of the network in real mode. Click the simulation mode to enter simulation mode. The simulation mode icon is located in the bottom right hand on the logical workspace. Okay. Part 2: Set event list filters. In simulation mode, the default is to capture all events. You will use filters to only capture DNS and HTTP events. In the event list filter section, click Show All None to clear all the checks. Okay, edit filters. And okay, click Show All None to clear all check. Sorry. Uh, Click Edit Filters under the IPv4 tab. Okay. Select DNS under the MISC tab. Okay. HTTP. Okay. Close the windows when done. The event list filters show DNS and HTTP as the only visible events. Part 3: Request a web page from the PC. You will open a simulated web browser on the PC and request a web page from the server. Click PC, click Desktop, and click Web Browser. Okay. A simulated web browser opens. Type into the URL box and click Go button to the right. Minimize the PC window. Okay. Paste and go. Run the simulation. In the Play Control section on the simulation panel, click Play. The exchange between the PC and the server is animated and the events are added to the event list. These events represent the PC's request to resolve the URL to an IP address. the server's providing of the IP address, the PC request for the web page, the server sending the web page into segments, and the PC's acknowledging the web page. Click View Previous Event to continue when the buffer is full. Okay, this is the one packet. Okay, okay. Part 5 Access a specific PDU. Restore the simulation PC window. Notice there is a web page display in the web browser. Minimize the simulated browser window. In the Simulation Panel Event List section, the last column contains a color box that provides access to detailed information about an event. Okay, okay. Uh, Click the color box in the first row for the first event. The video information window open. Part 6. Examine the content of the video information window. The first tab in the video information window contains information about the inbound and/or outbound PDU as it relates to the OSI model. Click Next Layer. Repeat the OK and read the description in the box below to layer to get an overview of how the change works. Examine the video information for the other events to get an overview of the entire exchange process. Well, I'll minimize this and okay. The first event is PC and OSI model. In layer, okay, destination, the DNS client send a DNS query to the DNS server. Layer 7, Layer 4 UDP source port 1025, destination port 53. And okay, this is layer 4. Okay, UDP is layer 4 is layer of transport. And layer 3 is IP header source IP and destination IP. Layer 2. Okay. Outbound. Okay. The next is this. Okay. Only DNS and HTTP. Okay, TCP source port 1025, destination port 80. Okay, okay, port Ethernet 0. Okay, in layers, out layers. Okay, change the destination and the source in layer 3 and layer 4.